Okay, so this lets you know that a scalene or oblique triangle can be divided into two right triangles with different areas. And now remember, these are unequal because it's a scalene triangle. Okay, so an equilateral triangle can be cut into two equal right triangles. Okay, an isosceles triangle can also be cut into two equal right triangles. And a scalene likewise can be cut into two right triangles, however they are unequal. And even a right triangle, which you wouldn't do this is because it's not necessary, but even a right triangle can be cut into two right triangles by drawing a height from its widest angle, which is the 90-degree angle, to its longest side, which is a hypotenuse. So in the right triangle, you draw a straight line from its 90-degree angle to its hypotenuse, and you divide that into two right triangles, which are unequal, which may or may not be, unless it's a right scalene triangle. And here we have a right scalene. You can also divide that into two equal right triangles. So without even going any further, you can find the areas and use these methods to find the sides of scalene or oblique triangles by recognizing that you can turn it into two right triangles, and then use the formulas that you know that apply to right triangles. Now here, we're going to apply the right triangle method to this oblique triangle here. Okay? Now I want you to write this down. So have this, we call this triangle A, B, C. Okay? So here we know that angle A is equal to 27 degrees. And angle B, that is not given to us, we have to find that. Angle C is 119 degrees. Now before doing anything, you want to get as much knowledge from you want to acquire as much data. Okay, this is our data table here. You want to acquire as much data as you can about the figure before you do anything, so you can find out the angle B by using the angle sum method. Angle B is equal to 180 degrees minus the other two angles. Okay? minus 119 minus 27 degrees. Okay, so that comes out to 34 degrees. So angle B is equal to 34 degrees. Okay. So now, here we're giving one of the sides for this triangle. Okay? And we want to find the other side. We want to find, and so we know BC is equal to 7. Line segment BC is equal to 7. We want to find line segment AC, and we want to find line segment AB. Okay? Now you could use the sine, ratio, the law of sines could be used, and you could also by finding another side, then you can further use the law of cosines, but you can use the law of sines all throughout this to find both of these sides. But I'm going to show you the right triangle method, show you how to use what you already know. Okay, so okay, so here, drawing another representation of this original. Remember this here, this is all 119. Angle C is 119 degrees, so when we don't know if we're cutting it exactly in half, but we're cutting into this angle once we form our two right triangles. Okay? Okay? So this entire angle here, this angle C, is 119 degrees. Okay? Okay, so now here, if we look at this triangle, okay, both of these, here, but first looking at now also after you draw your dash, be sure to label the point, label this point here. Okay, so now have a right triangle, DBC. Okay, we know angle DBC is equal to 34 degrees. We know this is 90 degrees. So we can find here angle DCB okay, angle DCB is equal to here, angle DCB equals 180 degrees minus 90 degrees minus 34 degrees. So that's 180 minus 90 minus 34, which that comes out to 56 degrees. Okay, so we now here we have a value. This is 56 degrees. Okay. Now then